Hello, in this video we're going to be covering section 6.3, which is on double angle and reduction formulas. So what we're going to be dealing with is, let's say we've got an angle sine of theta, of that angle theta, and it is maybe 1/2. Then what we're going to be talking about today is what would the sine value be if you doubled that angle. So maybe I have an angle of 60 degrees, what would my sine be if I then double it to take that angle of 120 degrees? Or maybe sine is 30, what would the sine be if I double that angle and evaluate for sine of 60 degrees? So our double angle formulas look like these. For sine of twice my angle, I would have 2 times sine of the original angle times cosine of that angle. So for example, if I've got sine of maybe 100 degrees, so that's 2 times 50, then it would be 2 times the sine of 50 degrees times the cosine of 50 degrees. So whatever angle we're doubling, we input that angle in for theta. Now cosine has a few different options. The first is cosine squared of theta minus sine squared of theta. Then to get to these following two, all they are doing is they are substituting with our Pythagorean identity, which is cosine squared plus sine squared equals 1. So here they subtracted my sine squared and replaced the cosine squared with 1 minus sine squared. And then in the second identity, they solved for sine squared and replaced sine squared with 1 minus cosine squared to get that third identity. Tangent has 2 options as well. So again, if I've got tangent of 100 degrees, it would be sine of 100 over cosine of 100. Or in terms of all sine without our double angle, we can have 2 tangent 50, 1 minus tangent squared of 50. So we're going to take a moment to practice this by using the fact that I give you an angle whose sine is negative 5/12. I'm actually going to change that to negative 5 over 13. That's what I intended to write when I typed this out. And that angle is in the third quadrant because I tell you that it is between pi and 3 pi over 2, which means that it is in quadrant number 3. So I'm going to go ahead and quickly sketch out where this angle is located. So this would be pi, and this would be 3 pi over 2. So that means that my angle is somewhere in this third quadrant. If I construct a triangle from that angle, I've got theta. My sine is negative 5/13, so that means that using SOHCAHTOA, my sine is the ratio of the opposite side to my hypotenuse. So opposite would be 5, and my hypotenuse would be 13. Since y values are negative in this quadrant, I can't think of that as a negative 5 to go ahead and get that ratio of negative 5 to 13. Now I'm asked to find the sine of 2 theta, cosine 2 theta, and tangent of 2 theta. So if I want to find the sine of 2 theta, I can use the above formula and say that sine of 2 theta is actually 2 times the sine of theta times the cosine of theta. Well, I have the sine of theta, so I know that the sine is going to be negative 5/13, but I don't know the cosine of theta. So I'm going to go ahead and find that. In order to find the cosine of theta, I need the ratio of the adjacent side, which would be that distance on the x-axis, over the hypotenuse, which is 13. So I don't know what that x value is or what that horizontal x-axis distance is, but since this is a right triangle, I can use my Pythagorean theorem to find it. So I have x, which is that horizontal distance that I'm trying to find, squared plus my other leg, which is a negative 5 squared, is equal to my hypotenuse, which is 13 squared. So x squared plus 25 is equal to 169. And subtracting 25 from both sides, I then have an x squared equaling to 144, which means that x is going to be a positive or negative 12. Now, since we are talking about the third quadrant where x values are negative, this will be an x value that is a negative 12. So here we're not really talking distance since we are working in a coordinate plane. If this triangle were not in a coordinate plane, then we would talk about it as a distance, which would be 12. but since we are talking about a coordinate plane, we are talking about a direction as well. So I want to include the negative because we are moving to the left on that x-axis 12 units. So this tells me that my cosine would be a negative 12 over a positive 13. So when I replace this for my cosine value, I've got 2 times negative 5 over 13 times negative 12 over 13. And now I'm able to simplify to find the value of sine of 2 theta. So sine of 2 theta would be negative 10 over 13 times negative 12 over 13, which would then be positive 120 over 169. None of these factors in the numerator or denominator have any that are in common, so I am unable to reduce this fraction. Moving on for my cosine of 2 theta, I need the cosine value squared of just theta minus the sine squared of just theta. Now I found the cosine value to be that negative 12 over 13, so I can use this form, but if I want to use strictly what I was given, if I want to just use that the sine is negative 5/13, then what I can do is actually just use this second form of my cosine function. So I can say instead cosine of 2 theta is 1 minus 2 times the sine squared of theta. Doesn't matter which one I use, they will all result in equivalent answers. So because I want to avoid any mistakes, maybe I made a mistake computing my cosine value, I'm just going to use strictly what I was given. So cosine of 2 theta would be 1 minus 2 times the sine of theta, which we're told here in the directions is negative 5 over 13. So simplifying, I've got 1 minus 2 times negative 5 would actually give me a positive 10 over 13. And then obtaining a common denominator, I've got 13 over 13 plus 10 over 13, which would be 23 over 13. So the cosine of 2 theta is 23 over 13. Now I'm going to go ahead and clean this up a little bit so I have room to solve for my tangent. So I'm going to go ahead and write that I found my cosine of theta to be negative 12 over 13. My sine of 2 theta was 120 over 169. And my cosine of 2 theta is 23 over 13. So now I'll go erase all this work that I have done for those two and find my tangent of 2 theta. Since I don't know what my tangent value is, I could find it using my triangle, but I think it will be a little bit easier for me to just go ahead and use the sine of 2 theta, cosine of 2 theta. So sine of 2 theta over cosine of 2 theta. I've already found the sine of 2 theta to be 120 over 169, and I found the cosine of 2 theta to be 23 over 13. So to simplify this, I'm going to take that denominator, and instead of dividing by the fraction, I'm going to multiply by the reciprocal of that denominator. So I've got times 13 over 23. I can reduce my 169 and my 13 to 13 and 1. And then from there, 23 is a prime number, 13 is a prime number, and 120 does not divide by either 13 or 23. So I multiply across. 120 times 1 is 120, and 13 times 23 is, according to my calculator, 299. So I've got 299. So the tangent of 2 theta is 120 over 299. Go ahead and take a moment to pause the video and try doing this next example, 631, from your notes on your own. Here I am told that my angle is in my second quadrant because we are between pi over 2 and pi. So I have my angle here with a tangent value of negative 3/4. So that tells me that if I'm looking at my angle theta, the opposite side would be 3 and the adjacent side would be 4. Now x values are negative in the third quadrant, so here I would have a negative 4, and my y value would be positive in that second quadrant. So to find sine of 2 theta is equivalent to 2 times sine of theta times cosine of theta. So in order to find sine of theta using SOHCAHTOA, sine is opposite over hypotenuse and cosine is adjacent over hypotenuse, so I need to find my hypotenuse. In order to find this hypotenuse, I'm going to use Pythagorean Theorem. So I'll go ahead and call that h. So my hypotenuse is equal to my 2 legs squared and added, so 3 squared plus negative 4 squared. So h is equal to 9 plus 16, or h squared, excuse me. So h squared is equal to 25, which means that h would be 5. Since we are talking about a hypotenuse, which is a distance, it's not a direction on our coordinate plane, it is going to be just a positive 5. So then my sine of theta is opposite, so 3 over 5, and it is positive in that second quadrant. Cosine of theta is negative 4 over 5, and it should be negative because we are again in that second quadrant. So sine of 2 theta would be 2 times 3/5 times negative 4/5. So that is 2 times 3 is 6/5 multiplied by negative 4/5, or negative 24 over 25. So the sine of 2 theta is negative 24 over 25. For cosine of 2 theta, if I go back to look at my relationships, cosine of 2 theta can be found using any of these 3 options. I will go ahead and I'll use my third one this time. It doesn't matter. We were given tangent in our example, and none of these use tangent. So I do need to use one of the values that I derived from my triangle. So I'll go ahead and use cosine squared this time. I do have both sine and cosine, so it doesn't matter which one I use, but I'm just going to select this one. So 2 cosine squared theta minus 1. And I know that cosine is negative 4 over 5, so 2 times negative 4 over 5, and it does need to be squared, minus 1. 2 times negative 4 is 16, 5 times 5 is 25, minus 1. 2 and 25 don't reduce, so I just multiply 2 and 16 to get 32 over 25 minus, and 1 I will write as a common denominator so I can add. 32 minus 25 is 7 over 25. So I found that the cosine of 2 theta is equal to 7 over 25. And last, I've got tangent of 2 theta. And going back, I will go ahead and use my sine 2 theta over cosine of 2 theta. Sine of 2 theta is negative 24 over 25, and cosine of 2 theta we found was 7 over 25. So just like before, I'm going to take my numerator and multiply by the reciprocal of the denominator, so that would be 25 over 7. And now I can reduce the numerator and denominator and multiply my 2 fractions to have negative 24 over 7, which does not reduce. So tangent of 2 theta is negative 24 over 7. And that'll bring us to the end of our video for today. Thanks so much for watching.